Okay, so in this lesson, we're going to continue solving quadratic equations, and we're going to remember we're going to do this by factoring. And so this will just be a mixture of problems based on the previous two lessons. So let's go ahead and solve the following equations. Number one, let's say we had x plus 3 times x plus 5 equal 0. Okay, so if you look at this, you have two factors that are being multiplied together. So x plus 3 times x plus 5. And so since you have two factors being multiplied together, remember you can use what's called the zero factor property. And the zero factor property says that if you have two or more factors, in this case let's say 2, let's say I have the factors a and b are being multiplied together, and their product is 0. In that case, that means that I know for certain that one of these has to be 0. Either a is 0, either the factor a is 0, that first factor is 0, or the second factor is 0. So that's what the zero factor property says. Now, so that's what we have here. We have two factors whose product is 0. Now, remember, in this lesson, these are going to be quadratic equations. So if you look, well, some of this will be quadratic equations, and you're going to see what I'm talking about in a little while. But in this case here, number one, you'll notice that this is quadratic because if I use the FOIL method, you see x times x, that's x squared. And so if you were to multiply it out using FOIL, you would have an x squared plus, let's see, that'll be 8x plus 15 equals 0. So that will be a quadratic equation. And so since I have factors whose product is 0, then according to the zero factor property, either this one's 0 or this one's 0. So he said each one equals 0, just like this. And notice I went from a quadratic to two linear. And from 2 semesters ago, you know that this solution is -3. And over here, that solution is -5. So you have two solutions. So your solutions are x equal -3 or x equal -5 is a solution. Okay? All right, now, number 2, what if you had 3x times 2x minus 1 times 3x plus let's say 7 equals 0. All right, now obviously this is not going to be quadratic because if I cover this part up and FOIL this, now this is going to be 6x squared, but that 6x squared being multiplied by 3x is an 18x cubed. So it's not quadratic because quadratic, the largest exponent would have to be 2. So you'd have to have x squared as the leading term. But it doesn't matter because what I want you to understand here is that we have two or more factors whose product is 0. Then we can use a zero factor property. And a zero factor property says that if you have two or more factors whose product is 0, then one of these factors has to be 0. Now, right here, this is really two factors, 3 times x, so 3 is a factor, x is a factor, but many individuals just go ahead and put this together, and it's fine. So you said each one equals 0, so you're going to say 3x equals 0, 2x minus 1 equals 0, 3x plus 7 equals 0, and you solve each linear equation. So I went from this cubic equation, and cubic because the leading term was x cubed, to 3 linear equations. To solve this equation, I'm going to divide both sides by 3, and 3 divided by 3 is 1, 1 times x is x, and you get x to be 0. So there's one of your solutions. Over here, add 1 to both sides, combine like terms, I get 2x equal 1, dividing both sides by 2, the other solution is 1/2. Over here, subtract 7, combine like terms, I get 3x equal negative 7. To get x by itself, I divide both sides by this coefficient, 3. And so simplifying, 3 divided by 3 is 1. 1 times x is x, so I get x to be negative 7/3. So those are your three solutions. So your solutions are x equals 0, x equal 1/2, and x equal negative 7/3. All right. Now let's look at this one. Number 3, you have x squared plus 20x equals 0. Now this is quadratic, obviously, and it is in standard form. Okay, so you always want to make sure it's in standard form. But the problem is that if you compare this with the previous two, it's not factored already. See, these were factored already. Your left side of the equation were factors, were product of factors. Here you had 2 factors. Here you had really 4 factors, 3 times x times 2x minus 1 times 3x plus 7. And over here, though, they're not listed as factors, listed as a polynomial. So you're going to factor the left-hand side. All right, so when I factor the left-hand side, I can factor out an x, and so I get x times x plus 20 equals 0. And now notice it is in factored form. So now I have 2 factors whose product is 0. And according to the zero factor property, I said each of these factors equal to 0. So I get x equals 0, or the other one is x plus 20 has to equal 0. So either this is 0 or this has to be 0. Over here, x is already by itself, so there's your solution. So your solution is 0. One of your solutions is 0. Over here, the other solution is negative 20. All right, so your solutions are x equals 0, x equals negative 20. All right, number 4. Let's suppose you had 4y squared minus 1 equals 0. So 4y squared minus 1 equal 0. Okay, so in this case, notice that it's not in factor form. It is a polynomial. And remember our strategy for factoring. Let's see if I still have a copy of it. But the strategy is that you look for a common factor. That's the first thing you would do. And so the GCF here is 1. Then you ask yourself, how many terms do you have? I have 2 terms. So then you want to ask yourself, is it the difference of 2 squares? Is it the difference of 2 cubes? Because of this subtraction in the middle. Obviously, it won't be the sum. It will be a difference. And remember, based on what you did in the previous chapter, when you talked about factoring, this turns out to be 4y squared minus 1. It's the difference of 2 squares because I can fill in these parentheses. This is 2y and this is 1. And so therefore, 4y squared minus 1 can be factored as 2y minus 1 times 2y plus 1. All right, so that's going to go here. 2y minus 1 times 2y plus 1 and equals 0. Don't forget, you got to say equals 0. You must say equals 0. You must keep these as equations. You must keep these as equations. See? All these were equal to 0. All right, so according to the zero factor property, that means that if I have two more factors whose product is 0, then one of them has to be 0. So either this one's 0, 2y minus 1 equals 0, or this one is 0, 2y plus 1 equals 0. And so you just solve for the variable y this time. Combine like terms. I get 2y equal 1. And getting y by itself, I would have to divide both sides by this coefficient. So dividing both sides by 2, one of my solutions is 1/2. So there's one of your solutions. Over here, subtract 1, combine like terms. I get 2y equal negative 1. To get y by itself, I've got to divide both sides by 2, the coefficient. 2 divided by 2 is 1. 1 times y is y, so I get negative 1/2. So those are your two solutions, 1/2 and negative 1/2. Okay, so notice here, again, just as before, you had a quadratic equation, and I ended up with two linear equations. Okay? All right, number 5. Suppose you had 30x squared minus 11x minus 30 equals 0. All right, so first of all, make sure it's in standard form, and it is. It's 30x squared. It's in standard form. The GCF is 1, so then notice you have 3 terms. So I'm going to go directly to the two binomials, and I'm going to factor this using FOIL and in trial and error. Okay, so I need two factors whose product is 30x squared. So let's try 6 and 5. All right, 6 and 5. Now remember, the possibility for 30, the possibilities for 30 is 15 times 2, 6 times 5, oops, 6 times 5, 3 times 10, 2, I already did the 2, and that's about it, 30 times 1. All right, so there's a possibility. So I'm going to try the 6 and 5 first because they're close together in the number line. It may not be right, but let's just try it, and if it doesn't work, we'll try something else. And so over here, this 30, let's do the same thing. Let's try 6 and 5 again. Now, remember, be strategic. You know you're not going to put the 6 here, because if you had put the 6 here, I'm going to go ahead and write it. If you had put the 6 here, that means you could take out a 6 from here, which means the original problem, you could have factored out a 6, and you can't. So you know you can't pull out a 6 here. You can't put a 6 here. So what we're going to do instead is, instead of putting the 6 here, let's put the 5 here, and let's put the 6 here and see what happens. Don't forget, you got to say equals 0. Equals 0. And now remember, the last sign is negative. That means that these signs in here have to be different. So one's positive, one's negative. So just look at let's just check ourselves. Let's just look at the outer and the inner. So the outer is 36x. The inner is 25x. And remember, the larger of these coefficients, which is 36, so 36x has to take this middle sign. That means this is negative and this is positive. And when I add them up, I do get negative 11x. 25x and a negative 36x is a negative 11x. So I know what my signs need to be now. So these are the correct order of the terms. So in order for the outer to be negative, that means that this sign right here has to be a subtraction symbol. So the operation here is subtraction. In order for the inner term to be positive, the operation here has to be addition. So 6x plus 5. All right. So there's your equation. Just go ahead and write it over. I'm just writing it over. And now look at what we have. We have two factors whose product is 0. So you need to be thinking like that. I have two factors whose product is 0. Well, I know that if two more factors have a product of 0, then I know for certain that one of them has to be 0. One of them has to be 0. There's no other alternative. So then you set each one equal to 0 by the 0 factor property. So either this one's 0 or this one is 0. So now remember, I went from a quadratic equation to two linear equations. So from 2 semesters ago, to get the variable by itself, in this case I would have to subtract 5 from both sides. When I combine like terms, I get 0 here, and over here I get negative 5. And so to get x by itself, I have to divide both sides by this coefficient of x, which is 6. 6 divided by 6 is 1. 1 times x is x. And so one of my solutions is negative 5, 6. Over here, I add 6 to both sides, combine like terms. Over here, I'm going to get 5x. Over here, I'm going to get 6. Again, to get x by itself, you have, since I'm multiplying by 5, the opposite is to divide by 5. So I divide by the coefficient. 5 divided by 5 is 1. 1 times x is x. And so I get 6 divided by 5. So there are your two solutions. So negative 5, 6, and 6 fits. All right. Let's look at this one. Let's see. I suppose we had 3x cubed plus 19x squared minus 72x equals 0. All right, so 3x cubed plus 19x squared minus 72x equals 0. All right, it is in standard form. Again, you want to look for GCF, and there is a GCF. The GCF here is just x. So I can pull out an x, and when I pull out an x, when I factor out the x, I'm going to get x times 3x squared plus x times 19x gives me 19x squared. X times a negative 72 gives me negative 72x. And that's going to equal 0. Don't forget, you got to say equals 0. Then we have to factor this trinomial. So I'm going to go off to the side here. I'm going to just rewrite it. Just rewrite it over here. And then you factor its two binomials. All right, so the 3x squared is easy. So in terms of FOIL, the f times f, the only possibilities would be 3x and x. So I'm going to say 3x and x. All right, now let's think about 72. All right, so two numbers whose product is 72, and use your calculator if you have to. For example, let's suppose you start with 2. 2 times, and you say 72 divided by 2 if you have to. 72 divided by 2, you get 36. All right, now most of you already do that. If you do 3 times, let's see, 72 divided by 3, you get 24. 4 will not go into 22. 5 won't go into 22. I mean 72. 5 won't go into 72. 6 will. So let's see. 72 divided by 6 is 12. So 6 times 12 is 72. 8 will. And I know 8 because 8 is a factor of 24. So you use these factors to help you. 8 is a factor of 24. 6 was a factor of 36, so I used it. 8 goes into 24 evenly, so use it. So 8 times, let me say 72 divided by 8, you get 9. 4 also goes into 24, and 4 also goes into 12, so use 4. I haven't used 4 right here, so you don't see 4 listed anywhere. Use 4. So 72 divided by 4 is 18. Notice I already used a 9, and I think that's about all the possibilities except 1 times 72. All right, so for 72, let's try the ones that are closer together in the number line first. So let's just try 8 and 9, see what happens. It may not even work, but let's just try it. So let's put now, be strategic again. If I put the 8 and the 9, you know 9 cannot go here, because if I put a 9 here, if I put the 9 right here, that means I can take out a 3. 3 goes in a 3 and 3 goes in a 9, which means that the quadratic here, I can pull out a 3 and I can't because of this 19. So that means that I would need to put the 9 here. So put the 9 here and then put the 8 here. Okay? All right, now I know that my last sign's negative, so that means these signs in here are different. So let's look at the outer and let's look at the inner. The outer is 27x, the inner is 8x. Okay? And I know that the larger of these, 27x, has to take this middle sign. So 27x is positive, 8x has to be negative. And when I do add them up, notice I do get 19x, which is what I wanted. So these are the correct order of the terms. And all I got to do now is fill in the signs. So in order for the outer to be positive 27x, I would need this to be a plus symbol. In order for the inner to be a negative 8x, I would need this to be a subtraction symbol. And so this right here is the factorization of this. But I've got to bring it right here. Okay, so don't forget the GCF though. That's still part of your factorization. So that's why it was important in the last chapter that you did problems where you had to factor out the GCF. So I get x times, and then I get 3x minus 8 times x plus 9, and don't forget, you got to say equals 0. See, equals 0 all along. Now look at what you have. I went from this cubic equation to 3 linear equations. Now remember, the title of the chapter is Solving Quadratic Equations. Well, technically, although this is cubic, you did have to, if I cover this up, this really is quadratic also. I mean, this, if I just did this, that would be quadratic also. So it's still part of that section, although the title's kind of misleading in this section. It is misleading. All right, but at any rate, notice I have three factors whose product is 0. So according to the zero factor property, one of those factors has to be 0. So either this one's 0, or this one's 0. So you just set each one equal to 0. So x equals 0 is here, and you get x by itself. So when I said this one equals 0, x is already by itself, so I know one of the solutions right away. One of my solutions is 0. Over here, 3x minus 8 equals 0. And over here, x plus 9 equals 0. All right, so if I solve for the variable x here, I'm going to have to add 8 to both sides, combine like terms, and so I get 3x equal 8. Since, I remember I got to get x by itself, since I'm multiplying x by 3, the opposite of multiplying by 3 is to divide by 3, so I'm going to divide both sides by 3. And so 3 divided by 3 is 1. 1 times x is x. The other solution is 8/3. And over here, subtract 9 from both sides, and combine like terms, and I get x to be -9. So those are your three solutions. All right, and then, let's see, let's look at this example. All right, so number 7, suppose we had 9y equal 6y squared. 9y equals 6y squared. All right, so let's go ahead and put it in standard form. It's not in standard form. See, this one was. Remember, standard form is where you had your polynomial on one side and zeros on the other. Now, it also helps if you put the polynomial in descending order. And then if you go back, they all were in descending order. So here, this is not standard form because 0 is not one of the sides. Now, what I'm going to do here is see my square terms on the right side. So I'm just going to bring the 9y over. That's one way to think about it. So in other words, I'm going to say minus 9y minus 9y. And so 9y minus 9y is 0. And so this becomes 6y squared minus 9y. Okay? Now, that's one way of getting 0 on one side and still having the y squared term being a positive coefficient. All right, so it helps if the y squared term had a positive coefficient. Now, the other way to think about this is I'm going to go ahead and rewrite this. So remember, if 2 equals 1 plus 1, I'm just writing this as an example, if 2 equals 1 plus 1, then you need to understand also that 1 plus 1 equals 2. So you see, all I did was just transpose the sides. So it's still a true statement. 2 equals 1 plus 1, or 1 plus 1 equals 2. So that's still a true statement. So what that means is that if 9y equals 6y squared, then that means 6y squared equals 9y. And so that's one way to rewrite it, to where here you just subtract 9y. It's kind of the same thing here, except you're going to have 0 on the other side. And so you get 6y squared minus 9y equal 0. So it didn't matter. You would still end up with either 0 equals 6y squared minus 9y, or 9y squared minus 9y equals 0. I'm going to stick with this one. So look for GCF. So the GCF here is 3y. So factor out of 3y. And you end up with 2y, because 3y times 2y is 6y squared, minus 3, because 3y times a negative 3 is negative 9y, equals 0. So notice I had equals 0 all along. Now remember, by the zero factor property, now really this is 3 factors. 3 is a factor, y is a factor, and 2y minus 3 is a factor. But I'm just going to go ahead and put these two together. So 3y equals 0, or 2y minus 3 equals 0. Okay? And so over here, to get y by itself, you're going to have to divide both sides by 3. And 3 divided by 3 is 1. 1 times y is y. And then 0 divided by 3 is 0. So there's one of your solutions. Over here, add 3 to both sides and combine like terms. A negative 3 and a positive 3 is 0. I get 2y equals 0 plus 3 is 3. And just like over here, you gotta get y by itself. The coefficient of y is 2. So I'm multiplying y by 2. The opposite of multiplying by 2 is to divide by 2. So divide both sides by 2. 2 divided by 2 is 1. 1 times y is y. So the other solution is 3/2, or you can say 1/2. It does not matter. All right. Now before I go, so those are your two solutions right here. Those are your two solutions. 1, 2, 0, 3/2. Before I go though, if your see how your factor here was a binomial, if your factor is a monomial, then that's going to imply that one of your solutions is 0. All right, so if it's a monomial, one term, see this was 2 terms, one term, you say that term equal to 0, then that means that variable has to equal 0. So you can see that every time. Okay. All right, and let's do, let's see if we need to do one more. Yeah, let's just do one more. So we're going to do this example. So we're going to solve this equation, 7x cubed minus 7x equals 0. And so notice that again, using our flow chart, you're going to factor out a 7x, that's your GCF. So when I factor out a GCF, I get 7x times x squared minus 1. 7x times x squared, 7x cubed. 7x times a negative 1 is a negative 7x. And don't forget, you got to say equals 0. Don't forget that. And now, remember in our flow chart, you always ask yourself, can I do anything further with this x squared minus 1? Well, yes, you can, because remember, x squared minus 1 is the difference of 2 squares. I can fill in these parentheses. This is x, because x times x is x squared. This is 1, because 1 times 1 is 1. So this becomes x minus 1 times x plus 1. So that's going to go here. So I get 7x times x minus 1 times x plus 1 equal 0. And now you just said each factor equal to 0. So technically there are 4 factors here. 7 is a factor, x is a factor, x minus 1 is a factor, x plus 1 is a factor. But I'm going to put the monomial together. These two monomial factors together. Okay, so according to the zero factor property, I got to set each one equals 0. So it kind of looks the same as this one. So I say each one equals 0. 7x equals 0, x minus 1 equals 0, x plus 1 equals 0. So based on the zero factor property, one of these, and I know for certain that one of these has to be 0. So if I solve for x over here, divide both sides by 7, I get x to be 0, because 0 divided by 7 is 0. Over here, I get x to be 1. Over here, I get x to be negative 1. So those are your 3 solutions, 0, 1, and negative 1. Now sometimes, see how you have 1 and negative 1 are opposites of each other? So sometimes you'll see the solutions written like this. Just to let you know, you'll see it like x equals 0 plus or minus 1, something like that. You may see x equals 0, x equal plus or minus 1. Okay, so you'll see the plus or minus 1 to indicate these two. But it's okay to just say x equals 0, 1, negative 1, or x equals 0, x equal 1, x equal negative 1. It depends on, well, in MyMathLab, it depends on how they want you to write it. Okay, so they'll probably, I think they want you to write it like this, x equals 0, comma, 1, comma, negative 1. Okay? All right, so that will end that lesson.